Have you ever stopped to think about how a banana gets to your plate? Not just the journey from the grocery store to your home, but the incredible process that begins thousands of miles away, deep in tropical farms, and ends in factories where machines and people work side by side to deliver one of the most consumed fruits on Earth. Bananas are more than just a snack. They're a global phenomenon. In fact, bananas are the most exported fruit in the world. Over 100 billion bananas are eaten globally every year. That's more than apples and oranges combined. From the bustling markets of India to breakfast tables in Europe and lunchboxes in the US, the banana is everywhere. But what many don't realize is just how complex and fascinating its production process really is. Behind that smooth yellow peel lies a journey filled with science, technology, hard labor, and precise logistics. In today's video, we're taking you behind the scenes. From the moment banana seedlings are planted in the soil, all the way through harvesting, factory processing, and even into the world of banana chips, we'll follow the fruit as it's cleaned, sorted, treated, and transformed. You'll see how farmers and factories work in harmony to keep up with global demand while battling pests, diseases, and the pressure of perishability. And yes, we'll also dive into how something as simple as a banana becomes that crispy chip you grab off the shelf. So, buckle up for a full circle look at one of the world's most loved fruits. By the end, you'll never look at a banana the same way again. Before a single banana appears on the tree, there's an entire operation happening below the surface. Quite literally, it all begins with the land. Farmers start by tilling the soil with powerful cultivators, churning and loosening it to create the perfect bed for planting. Then, the seedlings are arranged in neat rows, guided into the soil using specialized attachments on the cultivator itself. This isn't just manual labor. It's precision agriculture, aimed at maximizing yield from the very beginning. Once the seedlings are in place, the next critical step is moisture. Water misting systems spray a fine layer of mist over the newly planted rows, keeping the soil consistently damp. This constant humidity is essential because banana roots are shallow and sensitive. Without enough moisture, the young plants simply won't take hold. By maintaining a moist environment, farmers give each seedling the best chance of developing a strong, healthy root system. As the plants begin to grow, their timelines vary dramatically depending on the variety. Some banana plants can reach maturity in just 9 months, while others may take up to 20. Among the most commonly cultivated varieties are the Cavendish, known for its role in global exports, the starchy and larger plantain, and the reddish-skinned red banana prized for its unique flavor. Each has its own growth pattern, preferred climate, and consumer demand. Instead of replanting every cycle, many farmers rely on a clever natural system of propagation. From the base of a mature banana plant, smaller shoots, called suckers, emerge. These suckers can be carefully separated and replanted, continuing the cycle with genetically identical offspring. This method not only saves time and resources but also helps maintain consistency across a plantation. However, banana cultivation today faces mounting pressure from forces far beyond the farm. Climate change has introduced unpredictability to once stable growing seasons. Erratic rainfall, prolonged droughts, and rising temperatures are challenging farmers to adapt in real time. These changes not only affect plant growth but also encourage the spread of pests and diseases that previously stayed in check. In response, more and more banana plantations are turning toward sustainable practices. This includes using compost-based fertilizers, integrating pest management systems that reduce reliance on chemicals, and preserving biodiversity around the farms to create a more resilient growing environment. The shift isn't just about being eco-friendly. It's about survival in a changing agricultural landscape. At the same time, science is stepping in. Researchers and agricultural institutions are experimenting with banana plant genetics, developing new strains designed to resist disease, tolerate drought, and thrive in less than ideal conditions. Some of these genetically improved varieties aim to overcome long-standing threats like fusarium wilt or thrive with minimal water use. Banana farming is no longer a simple process of planting and waiting. It's become a high-stakes balancing act between tradition and technology, nature and human innovation, and it all starts with the soil, the seedling, and the silent hope for a fruitful season. Banana fields may look lush and green, But beneath the surface lies a constant battle. One that threatens not just the health of the plants, but the survival of entire farms. Some of the most destructive enemies are invisible to the naked eye. Diseases that creep in through the soil, spread by water, insects, or even on a worker's boot. Among the most feared is Panama disease, also known as fusarium wilt, a fungus that attacks the plant's vascular system, slowly choking it from the inside. Once it takes hold in a field, it's nearly impossible to eradicate. Then there's black sigatoka and its less aggressive cousin, yellow sigatoka, fungal diseases that attack the banana plant's leaves. They reduce the surface area for photosynthesis, weakening the plant and stunting fruit growth. Xanthomonas wilt, a bacterial infection, adds to the list of threats by causing premature ripening and rotting of the fruit, sometimes destroying entire harvests before a single banana can be sold. These diseases collectively cost banana producers billions of dollars every year in lost crops, increased maintenance, and abandoned farmland. To fight back, farmers rely on a range of protection strategies. On the ground, workers use handheld or machine-mounted sprayers to apply chemical treatments directly to infected plants and surrounding areas. In larger plantations, aerial spraying by agricultural aircraft allows for broad coverage in a short amount of time. Common pesticides include dimethoate and methyl-dion 25-EC, known for their effectiveness against pests like aphids, thrips, and mites that often act as carriers of disease. Equally important is the practice of trimming diseased leaves. By removing infected parts early, farmers can limit the spread and give the plant a better chance of recovery. It's a constant, labor-intensive effort, but one that can mean the difference between a thriving field and a failed crop. What makes this challenge even greater is the banana's vulnerability as a monoculture crop. Commercial bananas are nearly all genetically identical, especially the Cavendish variety. That uniformity makes them easy to grow. But it also means that if one plant is susceptible to a disease, they all are. This has sparked a debate over the future of banana farming. Should we move toward organic methods that emphasize biodiversity and natural resistance? Or double down on chemical solutions for short-term security? Meanwhile, scientists are racing to create a disease-resistant, super banana, using advanced techniques like CRISPR gene editing. These genetically engineered varieties could one day offer immunity to the most devastating diseases, potentially saving the global banana industry from collapse. In the life cycle of a banana plant, the harvest marks a pivotal moment, where months of care, labor, and patience finally yield fruit. But knowing exactly when to harvest a banana isn't guesswork. It's a skill, passed down through generations and refined by experience. Farmers look for specific signs: the angles of the fruit, the fullness of each banana, and the slight change in color from dark green to a lighter, more vibrant shade. When the ridges on the banana begin to round out and the fingers appear plump, the plant is telling you it's ready. Once the time is right, harvesting must happen fast, and it must happen cleanly. A dull blade or an imprecise cut can damage the banana stem, causing bruising that will show up later during transport or ripening. Skilled workers use sharp knives or curved harvesting tools to slice through the stalk in a single motion. The cut needs to be clean and controlled, keeping both the banana cluster and the remaining plant structure intact. The moment the bunch is cut, it becomes a race against time. Each cluster, often weighing over 30 kilograms, is carried manually by field workers, sometimes over uneven terrain, under intense heat, and across large distances. These aren't conveyor belts or automated lifts. These are people, often balancing bunches on their shoulders as they walk towards centralized collection points. It's backbreaking work, performed day after day, with remarkable endurance. In larger plantations, a simple yet effective rope line system is used to ease the burden. Workers tie the harvested bunches onto hooks that slide along elevated cables stretched across the plantation. This setup reduces the need for constant lifting and walking, allowing faster and more efficient transport from field to packaging areas. It's a blend of human effort and rudimentary engineering. Low-tech, but highly effective. Yet, beneath the rhythm of this process lies a deeper story. One about labor, inequality, and the human cost behind a seemingly ordinary fruit. Banana harvesting is among the most labor-intensive tasks in agriculture. In many countries, It's done by low-paid workers with limited labor protections. Some plantations rely heavily on migrant labor. Others, especially in Latin America and parts of Southeast Asia, see an imbalance in gender roles, where men dominate the physically demanding fieldwork while women are often relegated to less visible, lower-paid post-harvest roles like sorting and cleaning. The question now is whether technology can change that equation. Can banana harvesting be automated? The short answer is, not yet. While robotic arms and autonomous vehicles are making strides in crops like strawberries and apples, bananas pose unique challenges. They grow in large bunches, high off the ground, on flexible stalks that require precision and delicacy during cutting. Designing a machine that can replicate the judgment of a human harvester, recognizing ripeness, executing a clean cut, and navigating irregular terrain, is a feat that remains just out of reach. Still, innovation is on the horizon. Some tech startups and research institutions are experimenting with drone-assisted mapping, AI-powered recognition systems, and even robotic prototypes for test environments. The dream is a future where humans don't have to bear the full physical weight of harvest, where machines can support or even replace the most grueling tasks. For now, though, the harvest remains a human endeavor. Intense, physical, and vital. It's the moment when hard work becomes visible. And it all hinges on timing, precision, and a deep knowledge of the plant. As the banana bunches arrive at the factory, the clock continues ticking. These fruits may look sturdy, but they're highly perishable and vulnerable to damage if not handled properly. That's why the moment they reach the facility, the first tasks begin immediately and with precision. Workers carefully remove the soft cotton liners that were placed between the bananas back in the field. These liners have protected the fruit from bruising during transport, especially where clusters may have rubbed against each other or the ropes. Once removed, each bunch undergoes a size assessment. Larger bananas are separated from the smaller ones, and anything that doesn't meet export standards is redirected for local use or banana chip processing. A fine water spray follows, giving the bananas a second, thorough wash to remove remaining soil, debris, and any microbes that might still cling to the skin. Next comes trimming and sorting. Large bunches are cut into smaller, more manageable clusters, usually containing 3 to 6 fingers each. Workers use specialized scissors to make clean, precise cuts. These clusters are easier to pack and less likely to be damaged during shipment. At the same time, each cluster is visually inspected. Any signs of overripeness, bruising, or physical deformities lead to instant rejection. Only bananas that pass this stage are cleared for export-grade packaging. Once sorted, the bananas are placed on weighing trays. Batches are carefully assembled to ensure each box or container meets the exact weight specifications required by buyers and retailers. But before the packing begins, there's one final step: protecting the fruit from rot. A chemical solution is applied to the freshly cut stem ends to prevent microbial infection and slow down spoilage. It's a small but essential detail in maintaining shelf life. Now, the bananas are ready to enter one of the most overlooked but critical stages in their journey: cold chain logistics. To stay fresh over long distances, bananas are never stored at room temperature. Instead, they're kept in refrigerated containers and transported under tightly controlled conditions. Maintaining a constant low temperature prevents premature ripening and decay, essentially putting the fruit's biological clock on pause. Interestingly, bananas are almost always picked green, not because they're underdeveloped, but because that's how the industry works. If harvested when yellow, the fruit would ripen and rot before reaching its destination. Instead, once the green bananas arrive at distribution centers near their final markets, they're placed in ripening rooms. These are sealed chambers where ethylene gas is introduced to trigger and control the ripening process. Within days, the bananas turn their familiar yellow, right on cue for store shelves. It's a delicate balance of nature and technology. From hand-picked bunches in the field to climate-controlled ripening chambers halfway across the world, every banana that ends up in your kitchen has passed through a web of timing, tools, and technique designed to preserve freshness at every step. Once the bananas destined for fresh consumption are sorted and packed, the others, the slightly bruised, undersized, or simply surplus ones, head to another part of the factory, where their fate is much crunchier. This is where bananas become chips. And what may seem like a simple transformation is, in fact, a highly refined process. It begins with peeling. Unlike machines used for other fruits, banana peeling here is still largely done by hand. Factory workers in aprons and gloves carefully remove the skins, ensuring the white, starchy interior, known as the pulp, is left intact and unbruised. Each banana is handled individually, a surprisingly labor-intensive step that ensures quality right from the start. Once peeled, the bananas follow one of two paths. In the first, the pulp is pressed and ground into soft, pliable form using industrial grinders. This method results in chips that are slightly thicker, denser, and sometimes molded into shapes. In the second, and more traditional method, the bananas are sliced directly into thin rounds or strips using mechanical cutters. This slicing method preserves the banana's original texture and appearance, and it's especially common in factories producing classic, crisp-style chips. Then comes the heart of the operation: frying. Whether ground or sliced, the banana pieces are transferred into massive industrial fryers filled with hot oil. The type of oil varies depending on the target market and production cost. Coconut oil is often used in premium batches for its subtle sweetness, while palm oil is favored for its high heat tolerance and affordability. Each chip is flash fried at carefully controlled temperatures, allowing it to crisp up without burning or absorbing too much oil. As the chips leave the fryer, they aren't quite ready yet. They're still holding residual oil, which can make them soggy if not dealt with. That's where the rotating disc mechanism comes into play. The chips are funneled into a large spinning drum that uses centrifugal force to sling off excess oil. This step is key to achieving that perfect crunch without a greasy aftertaste. Once dry, the chips move down the conveyor belt into the seasoning zone. Here, flavor comes to life. The chips tumble through stainless steel mixing barrels where powdered flavors are dusted evenly across the entire batch. Depending on the destination, the flavoring can vary dramatically. In India, for example, banana chips might be tossed with chili and turmeric for a spicy kick. In the Philippines, they might be slightly sweetened with sugar and honey. Western markets tend to prefer a light dusting of sea salt, or sometimes even cinnamon. These variations are more than just personal preference. They're reflections of regional taste profiles, and factories adapt their flavoring lines accordingly to meet demand from multiple global markets. With flavor locked in, the chips are ready for packing. But here's where modern technology steps in. Conveyor belts carry the seasoned chips to a section of the factory run by eye-powered packaging systems. These machines are equipped with sensors and automatic weigh scales that precisely measure each portion. The right amount of chips is dropped into pre-formed polythene bags, which are instantly sealed with heat to preserve freshness. No human hands are involved here. Just speed, accuracy, and consistency, all at industrial scale. Once sealed, the chip packets are collected and moved to the final packing stage. Workers arrange them neatly into cardboard boxes. But it's not as simple as just filling a box and closing the lid. First, a vacuum system is used to remove air from the protective polythene layers that separate chip packets inside the box. This helps prevent damage during shipping and extends shelf life. Then, the boxes are manually taped shut, labeled with manufacturing and expiration dates, and stamped with a batch serial number. Each container undergoes one final quality check to ensure nothing has been missed. No leaks, no unsealed edges, no underfilled bags. While this part of the factory feels incredibly efficient, it also represents a broader shift in how banana chips are being treated. Not just as byproducts of banana farming, but as major commercial products in their own right. Today, banana chips are a growing global market. Countries like the Philippines, India, Ecuador, and Sri Lanka have become major exporters. They supply everything from small artisan snack packs to bulk shipments for supermarkets and airlines. What's driving this demand? For one, banana chips are starting to compete head-to-head with the reigning king of salty snacks, the potato chip. In many parts of Asia and Latin America, banana chips are marketed as a healthier alternative, lower in fat, often gluten-free, and sometimes even labeled organic. This shift in perception is no accident. It's a result of clever marketing and smart packaging. In fact, the packaging itself plays a huge role. Brands use earthy colors, eco-friendly fonts, and buzzwords like natural, handcrafted, or non-GMO to appeal to health-conscious consumers. It doesn't matter that banana chips are often fried just like their potato counterparts. What matters is how they're presented. The image of a tropical, handmade snack makes them feel special, even indulgent. But with that boom in popularity comes new challenges. The production of banana chips relies heavily on oil, and the packaging is often single-use plastic, raising environmental concerns. Some companies are exploring compostable alternatives or investing in more sustainable oil sourcing. But the reality is that scaling eco-friendly options remains expensive and complicated. Still, the industry continues to grow. Whether it's in a gourmet food store in Paris, a sari-wrapped market stall in Kerala, or a vending machine in a Tokyo subway station, banana chips are claiming their place as a global snack. They're crunchy, versatile, and born from a fruit that once might have been discarded. From pulp to packaging, every step in this process is designed not just for taste, but for scale, turning humble bananas into a product that moves across oceans and onto shelves in a matter of days. It's a journey of transformation that proves, once again, how the simplest foods often have the most extraordinary stories. From a tiny seedling planted in tropical soil to a golden chip in a neatly sealed bag. The journey of a banana is anything but simple. It spans months of patient cultivation, precise timing, and unwavering care from farmers who know the land like an old friend. It weaves through the controlled chaos of factories, where hands and machines come together to wash, cut, fry, and pack each piece with speed and precision. What might look like an ordinary snack is, in fact, the result of extraordinary human effort. Thousands of workers, many of whom spend long, exhausting days in the field or on the factory floor. Their labor is matched by scientific breakthroughs in plant genetics, agricultural practices, and AI-powered automation, all of which help meet the growing demand from every corner of the globe. Every banana chip you bite into carries with it a story of movement, of logistics that cross borders and oceans, of shipping containers cooled to the perfect temperature, and of ripening rooms that time the moment just right. It's a global operation, powered by the actions of people you'll never meet, in places you may never visit. And yet, their work ends up in your kitchen, your lunchbox, or your late-night snack drawer. So the next time you reach for a banana or a bag of chips, take a moment to think about the journey it took to get there. Behind that crunch is a supply chain so complex and interconnected, it touches almost every continent. If you enjoyed this deep dive into the world behind your favorite snacks, be sure to subscribe to our channel, share this video, and join us as we continue exploring the incredible systems that feed the world, one bite at a time.